Hey guys, I started doing some preliminary work on the Philco 60 chassis. It was quite filthy, but I've been able to clean it up fairly well. I removed the two early style electrolytics. They were held in by this clamp back here. Run it down like that. Notice that the cans on these have an insulated cardboard sleeve around them. That's because the negative side of these electrolytics does not go to ground, it does not go to the chassis. There's a resistor network used to develop a negative bias, so the can of this is actually the most negative voltage in the set. So you need to insulate it from the metal brackets here. There were two new electrolytics installed below. You can see down there the red guys, and the old ones were clipped out but left in place. Well, I'm going to take it a step further and actually cut these open and put a new cap inside. It's especially easy to do these because there's the cardboard sleeve, so I can simply use like a pipe cutter and cut these open and put the new cap inside and just glue it back, and the paper sleeve will cover the old seam. But while I've got those out, I figure I could work on other parts of the chassis. Particularly, I'm removing some of the worst rust right now. Not necessary by any means to get the radio playing. I just don't like the way it looks, so I've been putting on some navel jelly here, and apply a few coats of it, and that should get rid of the worst of the rust. Capacitor is in kind of rough shape, but I've been able to free it up so that it turns better now. Some of these plates were bent, and it wasn't even turning. It's also got some corrosion on it. I'll try to get that off as best I can. I lubricated and cleaned out the bearings there, so yeah, it rotates pretty well now. It's not, there's no gear reduction on this, so when you turn the tuning knob here, just a directorize, so it takes a bit of force to turn, but not too bad. Not too bad. I ordered up the parts for these, so I've got them all on hand. Basically just some capacitors. It's not too complicated a radio overall. I've also been studying the schematic, and I think I've got a pretty good handle on how this radio works now. This guy down here, which I thought was a coil, is actually the wire wound power resistors, and that's where the negative side of the two electrolytics goes to. And then it goes through a couple sections of this wire wound resistor here, and these taps are for the negative bias. And then the end of this is what is grounded to the chassis there. And it measures good, which is a good thing, because that would look kind of ugly to try replacing that with modern resistors. Kind of like the job somebody did up here, where they tacked in some modern ones and put a couple in series to get the proper value. I'll be replacing that with something more appropriate. Otherwise, I just need to replace a few capacitors, like this guy here, and probably most challenging is to get out these, let's see, I think there's 3 of these Bakelite capacitor block tub things. I need to unsolder all the leads to them, remove the one bolt there, melt out or chip out the insides, put new caps in there, and then remount them. And oh, this metal box here is actually a 5-section capacitor, so I'll need to unmount that, pry up these 4 metal tabs here, slide the old tar block insides out, put new capacitors in there, and then run the leads to the various connections. So I think what I'll do next is clean up the wiring going to the transformer and do a test on that to make sure it's good, because if it's bad, that's kind of a showstopper until I can track down a new one. After a few hours of the rust remover, here's what I've got. You can see that under the dirt and grime in the non-rusted areas is actually some nice cadmium plating. But where it rusted, see the plating's gone, and I still have some deeply pitted areas to work on. So what I may end up doing is painting this metal chassis with some silver paint. It's not something I like to do, and in fact I don't think I ever have done it before, but I think I'll make an exception on this one because it's going to look really splotchy and ugly after I get the rust off. So what I'll need to do is mask over the shields and the coils and such. Tuning capacitor I'll remove. I need to remove it anyways to replace the rubber mounts, which have rotted away. And I'll remove this transformer because I want to repaint it anyways. You can see in some areas it's got the nice shiny old black enamel paint, but along the top and the sides it's just gone down to bare metal. And while I've got the transformer out, I can test it. I don't think it'd be too tough to remove. Just solder a few wires down here. Capacitor should also be fairly easy to get out. I think you can see down in there when I wiggle it. There are the old rubber mounts. I actually picked up some reproduction ones from my Philco 70, which I never got around to using, so I suspect they'll fit on this set okay. You can see as it is, it's very wobbly, so they definitely have to be replaced. Something else just arrived in the mail today, which is a few knobs I scored off of eBay. So here are the 2 original black knobs that came with it, and these are the 3 I just picked up. I think when I clean these 2 up, they'll be a pretty good match. They look kind of brown and grimy right now, but I'll use some Novus number 2 polish and hopefully it'll be a good match. Now as for this, I believe this came from a Cathedral or some variation of an early Philco that had 3 knobs on it. This would have been for tuning. Now I believe these sets, all 4 knobs were the same size. I think I may go with the larger knob for the tuning, just for the heck of it. Because it is a direct drive, a larger knob will give me some more torque when I turn it. Yeah, I think it might be a nice look. Because another issue is that one of these knobs, must be this one, yeah, it has a bit of a chip out of it. Whereas if I go with these 4, they're all in good shape. But save that for later. Knobs aren't the most important thing right now. On the schematic for the Philco 60, they list the resistance readings for the primary and each of the secondary windings. So I'm going to use that as a first test to see if this transformer is indeed good. So I've got my HP410C warmed up and the lowest resistance range here. First I'm going to check the primary. One side goes right off this power cord and to this capacitor block here, and then right into the transformer. That would be this side here where it's always connected right to power. And the other side goes to a switch and then to the transformer. Oh, that's the power switch right here, and I've got that hooked up. And I am measuring right on 10 ohms, and you're supposed to measure 10.8. I'd say that's close enough. So next I'm going to check the high voltage winding, which is supposed to be 275. Now that's center tap, and they just say 275. My guess is that they mean from the outside, but it is possible they mean 275 from the center tap to either end. But I'm going to check the full winding first. So I'll do some poking around. In fact, I'm just going to cut these 2 red capacitors. I don't know, I'm going to be replacing them anyways, and they're kind of blocking my view of the transformer. Ah, that's much better. So the secondary windings go to the 80 rectifier, and that's this guy here. On these old tubes, the filament are the larger pins, which are these 2, I think. And the smaller 2 are the 2 plates. So this should be the secondary winding. Let's see what we get for resistance. By the way, I've taken all the tubes out, because if I left them in, the resistance of the filaments, I think, would affect my readings when I check the filament windings in the transformer. That's a good sign. Let's see. On the 100 range here, and it's reading about 300 ohms, so I would say that that's a very good reading. Now, while I'm on that same socket, I can check the filament winding for the 80 rectifier, which should be 2 ohms. This guy, and this guy. So this is where I think if I had the tube in there, which has a very low resistance, that I would be measuring the actual tube filament resistance and not necessarily the winding of the transformer. Alright, also a good sign is it should be very, very low. Let's see. It's kind of hard to read because the lowest range I have is R times 10. So it's actually reading lower than I would have expected because 2 ohms I think should be about here, and I'm way down there. So that's kind of a concern. Let's see if I do a dead short on the leads. It's right about on 0, so it's not a dead short. There's an awfully low reading. Well, I'm going to check the one last read, which is also supposed to read about 2 ohms, and that's the filament supply for all the other tubes. I've moved the meter leads over to the filament pins on one of the other tube sockets so I can measure this winding here. And I'm getting the same thing. It's supposed to be 2 ohms, but it's measuring more like 0.2 ohms. So what I'm going to do now is I'm going to use my digital multimeter and see if that gives me more what I'm expecting. So the 2 windings are reading lower than by a factor of 10, but then again they do measure about the same between the two, so it might be okay. Maybe the meter's just off a bit on that, because that is really at the bottom end of this meter's range. This is also measuring really low, like 0.3 ohms. Well, I guess the only way to really find out is to try to actually power up the transformer. Yeah, same thing on the 80 rectifier, about 0.3, 0.4 ohms, 0.5. Alright, well, I'll have to dig up my dim bulb tester and I'll use my variac, and I'll disconnect the, I should say make sure that nothing is hooked up that could cause problems. For example, I pulled out the 80 rectifier tube, so these 4 pins aren't going to go to anything, and so the set won't be getting power, so I'm not really worried about any shorts. And the other 2 lines just go right to the filaments on the tube socket, so I don't think there'll be any significant concerns with powering this up. But before I can do that, of course, I gotta replace the power cord. Oh, and I'll disconnect this capacitor in here, which is this guy on the schematic, which is really just there to clean up any RF that might get through to the power line or come from the power line. But you certainly don't need that to test a transformer, so I'll just disconnect that. Okay, I'm ready to try powering up this transformer. I've attached a new AC power cord. I bypassed that AC line capacitor, which is probably bad, needs to be replaced. I've got my meter connected to the type 80 filament pins. This is plugged into my little crude dim bulb tester. What this is it's an AC outlet that's wired in series with a light bulb socket. Now I've got a 60-watt bulb in here. The idea being if something shorts in the radio, that this will act as a current limiting device, and it also lights up so you get a visual indication that there's something wrong. That's going to an isolation transformer, then a variac. Basically, I'm being very paranoid. I don't really need an isolation transformer, but it doesn't hurt to have one. Got this dialed down to 0, so I turn the radio on and then slowly dial this up and monitor the voltage. Alright, so radio is turned on. Now remember, I removed all the tubes. What that does for me is without the rectifier tube being in there, the set will not get power other than the filament. So I don't have to worry about any of these old capacitors shorting out because there won't be any high voltage across anything. That's a good sign. Just barely tweaked the transformer up and I've got some voltage. halfway up now, 3 volts AC. Nothing smoking, light bulb's not on. I'm at about 105 volts. And yeah, we're looking good. It's about 6 volts AC, but remember there's no load on this. So I'm going to check the other voltages, and then I want to simulate having a tube in there by putting a power resistor that draws the same current as a Type 80 tube would. Because without any load on this whatsoever, I would expect the output voltage to be higher than it would be at normal operation, which would be 5 volts. So I'm kind of curious why this says 2 ohms and mine reads more like 0.2 ohms. Maybe there's just a mistake on the schematic and there should be a dot before that too. Now I'm checking the high voltage secondary winding, which goes to the 2 plates of the Type 80 tube. And I'm measuring about 775, which is great. The beeping you hear is my meter telling me that I'm approaching the limits, which is about 1000 volts on this particular meter. It's another nice reason to use a VTVM sometimes, because they can typically go to about 1500 volts. And here's the 6.3 volt winding. I'm getting about 7.3, but as I said, there's no load on this, so I expect the voltages to be higher. Now I'm going to do one final test with the transformer under load. To simulate the Type 80 tube being in here, I've hooked up a power resistor across filament leads, and I put the other tubes back in. You'll notice when I turn this on that the light bulb will light up briefly and then dim back down. That's because when tube filaments are cold, they have a much lower resistance and they draw more current. As the wire heats up, it draws less current, and the light bulb will dim down. Alright, here goes. And it lights up, it fades away. And there's the filament voltage across the simulated Type 80, which is right about 5 volts like it should be. The other tubes are lit up. There's the Type 42 output tube. The thing that's not lit up is the light bulb for the tuning indicator. Perhaps that's burned out, though I think I've got some spares around, so I guess I can give that a shot. I put a new light bulb in here, so let's give it one more try. That's better. Alright, cool. So now that I know the power transformer is good, I would certainly continue on with the restoration of this radio. Alrighty, now the real fun can begin. Recapping. Virtually all the capacitors in this radio are encased either in these Bakelite blocks or this metal box here. This wax paper cap is a repair at some point in its life, and this I think is the only original wax paper cap. So I am going to restuff these. Another option is you can leave these here and disconnect the wires like I've done and solder on new capacitors and maybe put terminal strips in here and there, like attached to this 1/4-inch nut. But it's not that difficult. I've done it before, so I'm going to restuff these. For example, this is this guy here. So just a single capacitor is 0.015 microfarad. And because it's on the AC line, it should really be a safety cap. So that's what I'll be putting in there. Once you unsolder the wires, there's just a 1/4-inch nut holding it in place. And there it is. So this outer part is Bakelite. And inside here is actually a capacitor encased in tar. When I've done this before, I melted the tar out. It's a little messy, but it goes quick. Just use a heat gun, hold this in a pair of like long nose pliers, and the insides come out quite quickly. I've also heard you could maybe put them in the freezer and then crack the tar out because it becomes very brittle. But I'll go with melting. Okay, so there's that one. And we got this guy here. I think there's 2 or 3 caps in this inside that block. A couple in here, a couple in here, a couple in here. And there's actually one inside of this, which is the tone control. So it goes, the shaft goes right into this, so I'll need to unmount that control. And inside this metal box is what this is. This shows 1, 2, 3, 4. But there's actually a 5th wire on mine, which isn't going to anything. I looked online and found out that there have been a lot of variations of the Model 60, and I believe some of them use this 5th capacitor lead. It doesn't look very neat, doesn't look very professional, so I don't know if that's how the factory did it or if somebody clipped that lead at some point in its life. But I'll just go with what I see, and when I rewire it, I'll just leave that alone. Oh, and then of course there's the 2 big electrolytics. I'll leave those for last. I can just temporarily tack in some electrolytics to get it running before I tackle these guys. Alright, so I just need to unsolder the connections to these guys, take them out, and get to it.